In the previous video, I introduced the concept of general relativity, but for some reason I did not care to explain it. General relativity, or in short, GR, is actually Einstein's attempt to describe gravity, very much like Newton's law of universal gravitation. However, unlike Newton's theory of gravity, in which the gravity is a force possessed by matter, Einstein explains gravity as a curvature of unified space-time caused by matter or energy. So the Earth orbits the Sun not because of force, but because of the curvature of space-time. The following video will help you understand this concept. It was due to this understanding of Einstein that later scientists were able to extract other wonders from this theory, including black hole, wormholes, and even singularities. Coming back to the point, this picture you see is quite famous. This picture was taken at the 5th Solvay Conference, a meeting where physicists would discuss the problems faced by the physics world. Soon after this conference, a young PhD, Georges Lemaître, met famous Albert Einstein in a surrounding park, showing Einstein his work on expanding universe. Lemaître argued that the universe in fact expands rather than being static, which is discussed in the previous video was in contrary to Einstein's belief. But consequently, Einstein was proven wrong 2 years later by the discovery of red-shifting galaxies by Edwin Hubble, which was discussed thoroughly in the previous video. Georges Lemaître was also one of the earliest proponents of the Big Bang theory. He suggested that observations from Hubble implied that if we go back in the time, the universe not only had a beginning, but even space and time began from that point. Sometime later, another advocate of Big Bang theory, George Gamow, and some of his PhD students in 1948 predicted theoretically that if universe had begun as described by Lemaître, then there must be an ancient relic from the after effects of the Big Bang, which they called a cosmic background radiation. Their theory was, as the light from the galaxies moving causes the wavelength of the light to increase, the earliest light formed after the Big Bang would be in the universe spread out equally. And because that light has traveled enormous distance relative to the distances of galaxies moving away, that light would have a greater increase in wavelength. And that wavelength would have increased so that light changes its wavelength from that of a visible light to a microwave. But unfortunately, at that time, there was no telescope powerful enough to capture those microwave radiation. Thus, their theory couldn't be proved. It was 20 years later that 2 astronomers working in Bell Laboratories were setting up their telescope for use for the first time that they finally observed the cosmic microwave radiation. There's a very interesting anecdote related to their discovery, which is that the 2 astronomers were originally using the telescope to receive radio waves from communication satellites. When they first pointed out the telescope towards the sky, they observed the mysterious noise. Because the two were unaware of George Gaimov's work, they did not think of it as cosmic microwave background radiation. At first, they thought it was a pigeon's dropping on the telescope that was accounting for this high noise, but even after cleaning it, the mysterious noise to them did not fade away. It was sometimes later that they received a call from physicists at Princeton University telling them that astronomers at Princeton were looking for the same radiation, which in fact was the aftermath of the Big Bang theory. The two astronomers published their data without prior knowledge of cosmic radiation, and in 1978 they won the prestigious Nobel Prize in Physics.